Welcome. I'm Wes Rosenberg, CTO at Levels Beyond. Today, I'll be talking about our core product, Reach Engine, and how we took a recent journey from a monolithic architecture to a more modern microservice-based architecture, and how Couchbase played a role in solving some of our challenges. Today, I'll split the session into three different parts. I'll start out by telling everyone what Reach Engine is. Then we'll dive into some of the architectural challenges that we encountered while trying to modernize the product. And lastly, why we chose Couchbase and ultimately what that looked like for us. So what is Reach Engine? Reach Engine is a media orchestration platform. Essentially, from camera to screen, our customers are using Reach Engine to drive pieces of very complex workflows, representing complex macro workloads, including acquisition of content, production and post, review and approve workflows, powering the media supply chain in an automated way, and removing those manual tasks that historically made the process take much longer and cost a lot more. Lastly, we are enabling or allowing users to use us as an asset management, content management system to be able to centralize their metadata and search and essentially discover and work on relevant content in their digital libraries. So you think about the media lifecycle and that supply chain, it all seems pretty simple, right? You essentially ingest, you store content and metadata, you transform it into something that looks different or maybe supports a different format, and then package it up and deliver it. Pretty simple. Our customers are looking to distribute to audiences or screens. This is perceived as generally an easy process. And our customers are spending a lot of money to shoot content, and their expectations are to deliver that content to screens fast and efficiently. However, the reality is that it's not simple and it's extremely complex. There's complexities around bringing in live feeds, bringing in files and the myriad of file formats that are out there in the media world. There's complexities around managing storage, archiving that storage, being able to access and search that content. There's complexities in post-production around dailies and editorials and social media and marketing and all the different formats and distribution channels that exist there. There's complexity in distribution itself, out to live TV and VOD and publishing cinematic delivery. And all the sub-platforms, transcoders, review and approve platforms, AI integrations, captioning solutions. There's a lot of different ways to do the same thing. And it gets pretty complex. So essentially, Reach Engine helps extract that complexity out of those workflows and orchestrates it in concert with what our customers' expectations are from camera to screen, so that those high value resources are freed up to do more high value work. And lastly, this is just a quick testament to where we sit and why we're the leader in orchestration. We've got an unmatched load and ability to move content through our platform. Unlike anyone else in the industry, we've got a number of key customers and players in media and entertainment, in sports, in social media, in marketing, as you can see by the logo board on the bottom of the slide. We're managing tens of millions of assets in Reach Engine. Hundreds of millions of assets are being orchestrated every day, translating into hundreds of terabytes of content being moved through the platform. We integrate with hundreds of different connectors, sub-platforms, and integration points, and essentially moving, at this point, it's well above 1 million workflow executions per day. So let's talk about some of the challenges we had in taking what the legacy Reach Engine platform looked like into something that was more modern. The complexity of everything I just talked about essentially ended up in a picture that looked like this. We supported essentially all kinds of different solutions for our customers. This led to the common big ball of mud architecture for a variety of reasons. We had no real architecture in place to begin with. There were sloppy and lazy coding practices. There was no perceived concepts of business context in the code base itself, right? We were essentially, every time a customer asked for a new feature or capability, we were just bolting it on and not thinking through the business context and the domains that it supported and the end-to-end workflows that we were trying to build in. There was developer turnover. You know, this code base is well over 10 years old. So, you know, we definitely had a changeover in who was working on it and different approaches to coding and some level of architecting throughout those years. That led to code entropy. That led to essentially an unmaintainable code base that was difficult to make changes to, extremely difficult to maintain code quality, and led to essentially, you know, a lower customer expectations that you know, made it difficult for us to keep up with what our customers were asking for. So as we thought through what our future state would look like, you know, we wanted to think about what we were trying to achieve and where we wanted to go and what objectives we were trying to get out of modernizing the Reach Engine platform. So, you know, hybrid cloud, it certainly something everyone talks about nowadays. I think especially this year with pandemic becoming sort of, you know, front and center and people going remote and workforces being more distributed. We want to be able to support the hybrid cloud, both from a remote workforce perspective and essentially from remote location perspective and supporting our customers, multiple data centers and multiple shoot locations and multiple places that they were allowing customers to come or their users to come in from. We extended the hybrid cloud concept to, you know, essentially pay for what you use, don't pay for what you don't use. And so that, you know, that covered things like supporting low cost or sunk cost storage solutions. You know, our customers already have, some of them have petabytes of content archived and are in use daily. We were not going to ask our customers to snowball up petabytes of data into an S3 bucket or some sort of, you know, glacial archive. We wanted to leverage the existing storage solutions. So, and existing transcoders, existing, you know, other pieces of the work flows that they had in place that were already occurring or taking place on their on-premise systems. We didn't have really any concept of analytics in the platform. So we wanted to build that in, but we wanted to do it in an isolated way that we were, you know, not affecting the operational workloads at all. To that extent, we wanted to extend our distributed computing capabilities. You know, we were essentially historically known as an on-premise system. We could scale within that on-premise system, but, you know, to go to multiple locations and multiple sites became a little bit more than just a simple lift. So obviously out of distributed computing, we wanted increased availability, reliability, and definitely scalability. And then, you know, to reference back to the pay for what you use and don't pay for what you don't use, we wanted to reduce the total cost of ownership for our customers. You know, our approach here was in the hybrid cloud was to go cloud first and to start to offer up services that were highly scalable and elastic in the cloud for our customers. So that involved reducing risk for them. So every time we unveiled a new feature or moving something into the cloud, we wanted to minimize the impact as much as possible. We wanted to minimize their resource utilization on their side and start to take advantage of the compute in the cloud versus asking them to add more bare metal servers to support more virtual machines in their on-premise systems. And lastly, sort of inferred it before, the monolith and the big ball of mud made it very difficult for us to keep up with our customer requests and demands. We wanted to go back to the good old days of startup-like speed and being able to innovate and pump out features and capabilities essentially at the speed of development. You know, when you're talking about on-premise deployments, we were at quarterly releases, you know, sometimes even less frequent than that. And our customers sometimes didn't want to upgrade for many reasons, whether they were, you know, a sports team in season, you know, they don't have time, they're 24/7 with, you know, sports around the globe, or they just, you know, they're happy with what they have. And we were not delivering valuable features that were showing or enticing them to upgrade. So we went again with future state. You know, we thought about what would a perfect or much better architectural approach look like. You know, we started to look at what was inside the big ball of mud. There were clear concepts and services that we were exposing. Internally, it was a giant ball of spaghetti, but externally, there were clear, defined, bounded contexts at the API. So we sort of went internal to the platform and started to look at how do we separate some of those concerns, right? How do we start to build an architecture that allows us to scale, that allows us to be more reliable, that allows us to fail and recover in a clean way, and to be able to essentially handle the inherent chaos of the media supply chain, media workflows. So essentially, if you go inside out, we did not have an event-driven architecture anywhere in the platform, and we decided that that was where we wanted to start. You know, that allowed us to decouple the entire platform, right? I mean, if you looked at the code base of the monolith, again, tightly coupled, there were all kinds of, you know, compounded class dependencies, you know, calls being made directly to databases, circumventing APIs. So the first thing we did is said, okay, we're going to put in a message bus. That's going to be the central way for everything to communicate in the platform. We're going to send in a message. Something else is going to figure out if it needs to process that message. We don't need to worry about essentially building in that, you know, layer of connectivity, because the message bus is going to help us prioritize and queue up and handle that load and be able to scale out the core messages and processing of those messages within the system. So essentially going front towards the lower left, obviously we wanted to build in microservices. I mentioned it at the front of this conversation. We started to look at the big ball of mud and through event storming and through some really good product definition, started to understand that we essentially had two groups of services in the platform. We had sort of the customer-facing services known as workflow, and then more internal, what we call here entity services, things that were the core domain of the platform. Asset management and search and archiving. And then workflow services were those things that were enabling our customers to connect other sub-platforms and libraries and tools through the workflow. Looking at the upper right, that allowed us to build in a really nice interface for our connector services, all the other platforms that we're connecting to, and simplifying throughout that workflow process. We essentially also built off of the connector services, sort of a little a lot decoupled from the message bus, was a data lake and the ability to run analytics and AI ML through the gigabytes of data that we were collecting through all these workflows and from all our customers. And as a side note, we built in a separate connector API essentially for the connector services in the upper right are more media oriented, things like transcoders and captioning software, review and approve solutions, NLE tools. The things on the lower right, the business applications, were things like Trello and Monday and project management tools that were just as important in the workflow because it allowed our customers to ultimately see where their content was and how it was moving through their workflows and through the system. And moving further down to the left, we continued our API first mentality. Essentially, everything sat behind an API, a clean, well-documented, standardized set of APIs that allowed us to do two things from a user experience perspective. One, we could build in a personalized user experience. So this manifested in two ways. One, we now had the ability to present to a user on the platform for any number of our customers content that was relevant to them, jobs that they needed to work on or that they had sent through the system and what their status was and where that content was and if there were any issues and how they could resolve those issues. And then shift over to administration and maintenance. We gave our users a super simple way to manage users and roles and permissions through the platform, manage workflow, create new workflow, kick off workflow, and essentially visualize how the system was performing and if there were any issues within that system, and give them ways to resolve those issues. So why did we choose Couchbase? Asked myself that question many times through this process. There were essentially three main parts to this in my head. There was the ability to be agile. And I just don't mean that from the agile practice perspective, but the ability to be agile with our customers, both with our customers and with the code base. So we wanted to limit communication between our infrastructure and interface. The big ball of mud had become extremely complex with what was talking to what. So we wanted clear separation there. We needed data on a per job basis. That agility manifested in Couchbase's key value store, right? Leveraging fast data access. We wanted zero dependencies on relations. So a job came in with a payload. We wanted super fast sub-millisecond access to that payload so we could continue to work on it in an efficient way. And then message reordering. We and messages reference it later on too, but we essentially wanted to be able to reprioritize and handle failures and retries within the workflows fast and efficiently. And lastly, when it came to being agile with our customers, we wanted to minimize impact to their existing instances of Reach Engine. And we were able to do this essentially with the autonomous operator and deploying Couchbase within a Kubernetes cluster. It minimized the amount of work that our customers' IT staff had to take on in order to help manage and maintain the existing Reach Engine instance. And then distributed computing, right? Couchbase's eventing nodes, that was huge. That helped us essentially build a little bit of a advanced algorithm around the core message bus. That fast access that I referenced before on payloads, we were essentially able to build a set of virtual queues before it hit the core message bus to allow faster processing of prioritized packets, faster reordering when things failed. We were able to, and I'll mention it now, but from a security perspective, we were able to very easily provide per customer isolation when it came to those workflows and workloads. from a distributed perspective, we wanted to be able to orchestrate and essentially, again, minimizing the impact on our customers, orchestrate the existing local job states up into a centralized master control in the cloud. And basically what that means is we wanted to take the existing implementations and workflow implementations that were sitting on premise and be able to push states of change and anything else relevant in that in the workflow data-wise up to a central place to where we could orchestrate the full end-to-end workflow from a central place in the cloud. And so it gave us the ability to essentially move data and content or reference content from different places on the globe. So if a certain piece of the workflow all of a sudden needed a video clip that was on the East Coast, but this person was working on content on the West Coast, the master control knew where that was and could grab it for that person and tee it up as they needed it to essentially minimize wait time and minimize the amount of content or the amount of bytes essentially moving around from location to location. And then built into Couchbase, was this awesome way to observe what's going on via Prometheus and all kinds of monitoring and built-in metrics. That absolutely unlocked our ability to deploy both on-prem and in the cloud and essentially aggregate all that data and aggregate all the statistics moving around and really be able to visualize that in a really clean way for our customers so they knew exactly what was happening, how it was happening, and when it was happening. And then the last part I'll mention on security, I already talked about the customer isolation aspect, but immutable data. We're pushing a lot of content, a lot of workflows through our platform every day. We wanted to ensure, from a security perspective, that the payloads that were streaming through our queues were not changing from underneath us. And Couchbase at its core doesn't necessarily give us that, but the Couchbase APIs allowed us to build interfaces that made it possible for us to lock down the documents sitting in those buckets, and really allowed us to think about the architecture and the implementation of especially the cloud side of this, multi-tenant cloud implementation a lot easier. So we could have done this really with any NoSQL database, quite honestly. But it essentially was Couchbase's core architecture, that the multi-dimensional aspect of this, the way isolation of jobs and workloads from node to node, from a data node to a query node to an index node to analytics to eventing, that essentially inspired us to build the previous picture, the cool 3D picture that I had up before, into a better platform and help modernize our code base. I definitely give a lot of credit to what the Couchbase engineers have done with architecting a super scalable and distributed product. And that really, really did inspire us to do the same thing. So spend a little bit of time here just going from where we were to where we are. This essentially is what we had. This is very oversimplified, but at the same time kind of shows what kind of place we were in. We had essentially an application sitting on a couple servers. Yeah, it was sort of load balanced, but there's a lot of state from in this monolithic architecture. We had a Postgres database. We had the ability to search with Elasticsearch. We had an API sitting in front of all this and a user interface and the ability to manage media and assets through those workflows. And that was essentially it. So remember, keep in mind, we wanted to minimize the impact to our customers, right? So we didn't want to just lift and shift them into the cloud and say, okay, you're cloud-based now. Good luck with that. You know, they had petabytes of content. They had existing workflows in place, hundreds of them in some cases. You know, migrating to the cloud in some customer cases meant that they were going to be down for a day, maybe more, right? Depending on what kind of issues we came up against with respect to implemented workflows and the data that needed to be migrated. So we wanted to build essentially master control in the cloud first, um, and essentially help peel away certain services and capabilities that were sitting on-prem and give our customers that same capability in the cloud. So we took this on in a couple different ways. We explicitly stopped making changes to the monolith, right? If we had to make them, they had to be very deliberate and very minimized. We deployed a local instance of Couchbase on premise. Again, using the autonomous operator, it sat in a Kubernetes cluster. Talked about, you know, the pros of why we did that previously, but that allowed us to essentially decouple the data movement on premise. So we started with building in essentially a status service. That's the second green box there, right? That was essentially allowing us to decouple job status and move some of that orchestration into the cloud versus keeping it all on-prem. And so that immediately allowed us to start to distribute workflow and workload and orchestrate it from that master control. We deliberately used Couchbase for all our new data models. The JSON approach and, you know, schemaless design allowed us to essentially not be afraid to make mistakes, right? And we all know you get into a relational database and you have to add a column or change a table, and it becomes a maintenance nightmare. The schemaless approach and using JSON documents in Couchbase allowed us to innovate and iterate on versions of documents and data schemas without really having to worry about breaking previous models, which was awesome. And essentially, you know, that led us to building in things like an organization management service, building in increased workflow services where we could decouple it from the monolith and really focus on getting jobs through workflow steps and pushing that the important data into Couchbase, using an event node to push it out up into the cloud, but also at the same time using the event node to push it back into the original legacy database. So that helped us minimize changes to the monolith. And really, when it came to deploying new capabilities, features, and services for our customers, we had very few times where we actually had to touch the monolith when upgrading them. There were initial cases where they had to upgrade to the latest platform version, but once they were at a place where we had decoupled a lot of this and put Couchbase into place, the number of times that we'd had to touch the monolith and change code there became a lot less, and allowed us to deploy services and capabilities for customers both in the cloud and on premise a lot easier, a lot faster. We could deploy a new feature or capability in the dark and turn it on when they were ready for it, which was awesome because that gave them a completely different experience. You know, it's like, oh, that's already running there. Well, how do I see it, right? Versus I don't want to see it because it's going to break something. So that completely changed the dynamic with our customers and getting them, you know, a more reliable, more available, more scalable system here. So that's our story. If there's anything else you want to learn about Reach Engine, or if there's anything I can answer at the end of this session or after Couchbase Connect Online is over, feel free to reach out. My email address is up there. Our website is up there. Our blog/news link is up there. Again, if you have any questions on what else we did with Couchbase, you know, this is a very high level description of what we did. I didn't go into really any super deep detail around, you know, what indexes we may have used or index choices we may have used. what we really did with, you know, the event nodes or the analytics nodes. But again, you know, this was meant to sort of show you that Couchbase really did help us go, you know, advance the platform from something that was very, in my mind, antiquated to something that is very, very much modernized and easier to work on. So thank you. I hope everyone is staying safe out there. Enjoy the rest of Couchbase Connect.